meters or in meter. Similarly, at that instant, the position vector of the second particle RB is 3 minus 2t square I plus minus 60j meters. So this is the problem, that is particle A of 1 kg mass, particle B of mass 2 kg, they are moving in xy plane. At a particular instant, their position vectors are given by this as a function of time. These position vectors are dependent on time, therefore they are now in motion. So how to calculate the velocity? First find out the velocity of center of mass. Find the velocity of center of mass. Okay, or otherwise we'll write find 1. The velocity of center of mass, acceleration of center of mass. Third one is linear momentum of center of mass at t is equal to 1 second. At t is equal to 1 second, we have to calculate velocity of center of mass, acceleration of center of mass, linear momentum of center of mass. What is the procedure? First thing is how center of mass velocity is obtained. VCM as per definition is, since there are two particles are involved, MA mass of the first block, velocity of the first particle, MB VB divided by EMA plus MB. So if VA and VB are instantaneous velocity of the blocks or particles, the velocity of center of mass we can calculate by this form. How to calculate VA? But VA is dRA by dt. Differentiating R position vector with respect to time, we will get velocity of A particle. So this differentiation is 0. Here we will get 0I plus 3 plus 4t j meters per second, differentiation of RA with the time. Similarly, velocity of B is obtained by differentiating RB with the time, that is equal to here minus 4ti plus minus 6j meters per second. So this is velocity of B. Substitute these two values in this expression. We get VCM therefore is equal to MA. MA is 1 kg into VA. VA is 0I plus 3 plus 4t j plus 2 kg into minus 4ti minus 6j divided by 1 plus 2. So that is the velocity of center of mass, instantaneous velocity. Therefore, 3 plus 4ti minus 8ti minus 12j by 3 meters per second. We can further simplify 3 minus 80 minus 80 minus 40, 3 minus 40, 40 is there, 80 is there, 3 minus 40i minus 12j divided by 3. So this is velocity of center of mass. Next one is acceleration of center of mass. For calculating the acceleration of center of mass, formula we write ACM is equal to MAAA plus MBVAB divided by MA plus MB as per the definition, and AA is obtained as dVA by dt. So we differentiate velocity which obtained here after differentiating RA. The same once again we differentiate with respect to time to get the acceleration. That is nothing but 0I plus 4j meters per second square. That is the acceleration of A. And acceleration of B is dVB by dt, which is equal to minus 4I meters per second square. This is going to be zero differential. So therefore, acceleration of center of mass comes out to be MA. MA is 1 kg, AA is 4j, plus MB is 2 into minus 4I divided by 3. That is minus 8I plus 4j by 3 meters per second. So this is how we calculate the acceleration, instantaneous acceleration, which happens to be same at every instant, therefore which is a constant acceleration. Then how to calculate the linear momentum of center of mass? Linear momentum of center of mass PCM is equal to m into VCM. So VCM already we have calculated, m is MA plus MB into VCM. VCM just now we have calculated, substitute that VCM here, this is 1 plus 2 into VCM. So from that we will be able to calculate the linear momentum. Now at given time, at t is equal to 1 second, substitute t is equal to 1 here in those values, you will get the corresponding numerical values at that instant of time. This is one of the examples. Next example, we consider a boat problem. Let us assume that a boat is floating at rest on a still water lake. Let us assume that a boat of length 5 meter. A boat of length 5 meter is floating on water, still water, initially at rest. A person of mass, a man of the mass 40 kg. 40 kg is standing at one end of the boat and mass of the boat be 80 kg. Mass of the boat. Mass of the boat is 80 kg. A boat of mass 80 kg and length 5 meter is floating on water, still water, and the person is standing at one of the ends of the boat, one end of the boat, and let the near end, that is the person where the person is standing, that end of the boat, let it be at a distance 3 meter from the shore. Boat is 3 meter from the shore, having a person of 40 kg standing at one end, and the boat is of 80 kg mass and the length of the boat is 5 meter. Now the person starts walking from this end of the boat to the other end of the boat. Then the distance he has to travel in the boat 5 meters. Now after traveling 5 meters inside the boat, reaches the other end of the boat. Then what is the effective distance? What is actual distance of the person now from the shore? At what distance he is from the shore? Calculate the distance of the person from the shore when he is walking from this end of the boat to other end of the boat. That is the problem. We have to calculate actual distance between the person and the shore. If the boat does not move, then it would have been 8 meters. But what happens as the person walks this side, boat will be moving towards left. Why should the boat move towards left? Here we analyze now what causes the boat to move. The boat is initially at rest, floating on water. Weight of the person and boat are downwards. Water buoyant force is upwards. Both are equal, balanced. That's why boat together with the person are floating. In the horizontal direction, there is no force. because water surface does not exert any force on the horizontal direction, we assume. So therefore, no net external force in the horizontal as well as in the vertical direction. But because of that,